Good morning, good afternoon or good evening, depending on when you're watching this video. Now we're going to move on and express a cos x plus b sin x in other forms. Now we've been writing it as k cos x minus alpha, but we can write a cos x plus b sin x in any form. K cos x minus alpha, k cos x plus alpha, k sin x minus alpha, or k sin x plus alpha. We have expansions for all of these. In exactly the same way, we could express it in one of those terms. Indeed, we don't always have to use the letters k and alpha. So let's look at another example. If we were asked to express minus cos theta minus sin theta in the form r sin theta minus alpha, it's exactly the same type of question, and we begin in exactly the same way. We make them equal to one another. So minus cos theta minus sin theta is equal to r sin theta minus alpha. And as before, no shortcuts. The exam board expect you to use your expansion and write it in an expanded form. Now the expansion for the sine is different. So you would make sure that you're familiar with your sine expansion and use your sine expansion. Now again, it's minus cos theta minus sin theta. To keep it in the same format, I've written the number that would be there. It's minus 1 cos theta minus 1 sin theta. And my expansion would be r sin theta cos alpha minus r cos theta sin alpha. And then we begin the process of matching them up. Now this is a bit different again. Here we've got cos theta here, and when we look over to this side, here's cos theta here. So it's not just the same as before. First of all, identify where is your cos theta. There it is there, and there it is there. And again, I've highlighted the coefficient. Now again, can you see then, minus r this time, minus r sin alpha is equal to -1 when we are matching up the coefficients here. And here's sin theta on the left-hand side, sin theta on the right-hand side. And I've highlighted the coefficient. The coefficient there is -1, and here it is r cos alpha. So r cos alpha is equal to -1. So it's important that you do your expansion correctly. It's very important that you can match these up and write the correct statement down. So we've written minus r sin alpha is equal to -1. Now I'm going to divide both sides through by -1 to get r sin alpha equals 1. Divided both sides through by -1. And I've got r cos alpha equals -1. So that's us back. After having reached this stage, it's exactly the same as all the previous examples. R sin alpha is 1, r cos alpha is -1. So to get r is equal to the square root of 1 squared plus -1 squared. Square root of 1 plus 1, r is equal to the square root of 2. So that's us found that value. And again, the next thing we have to find is alpha. So again, we do it in exactly the same way. We're going to write r sin alpha over r cos alpha. Again, we're going to cancel that off. R sin alpha we've written down as 1, so that's 1 over r cos alpha, -1. So sin alpha over cos alpha is equal to tan alpha is equal to -1. So again, we've got to decide which quadrant does this lie in. Again, we go back to this thing. R sin alpha is 1, so the sign rather is positive. Where is the sign positive? In here and in here. R cos alpha is equal to -1, so the cosine is negative. Now, if the cosine was negative, where would your answers come from? Where is the cosine negative? It would be in here or in here. So this time, it's the second quadrant that our answer is going to come from. So alpha is in the second quadrant. And we are solving tan alpha equals -1. So again, we want to solve tan alpha is equal to 1. That won't give us our answer, but it will give us our answer in the first quadrant. Now again, this is an exact value. Tan alpha equals 1. So you should know that alpha is equal to 45 degrees. Now it's radian measure, so we would have to write that as pi by 4. Now that's the answer in this first quadrant. Pi by 4, remember that's just a quarter pi. But it's this quadrant that our answer is going to come from. Now it's 1 pi minus 1/4 pi. So 1 pi, sorry it's a wee bit messy, 1 pi minus 1/4 pi. So that's equal to 3/4 pi. So in the second quadrant it would be 3/4 pi. So we've found alpha. Alpha is equal to 3/4 pi or 3 pi by 4. Doesn't matter, it's exactly the same thing. 3/4 pi. So let's write that out again. We had minus cos theta minus sin theta. minus cos theta minus sine theta is equal to r sine theta minus alpha. R sine theta minus alpha minus cos theta minus sine theta is equal to r, then we found that to be root 2, sine theta minus 3/4 pi. Okay, let's do a second example. Let's look at number 2. Express cos x plus root 3 sin x in the form, this time, k cos x plus alpha, and alpha has to lie between 0 and 360. So again, really the same format each time, make them equal to one another. Now I've written 1 cos x plus root 3 sin x equals k cos x plus alpha, made them equal to one another. And I've used the expansion this time for cos a plus b. It's essential that you write out the expansion. So 1 cos x plus root 3 sin x equals k cos x cos alpha minus k sin x sin alpha. Again, the next important thing is, where is the cosine? Here it is here, cos x and cos x. So I'm going to highlight the coefficient in yellow. K cos alpha is equal to 1. So I've written that down. The next thing I'm going to have underlined is there's sin x on that side and sin x over here. And I've highlighted the coefficient, minus k sin alpha. And the coefficient here is root 3. So I've written down minus k sin alpha is equal to 3. And again, it's not minus k sin alpha, it's k sin alpha. So I'm going to divide both sides through by -1. So once I've got k cos alpha and k sin alpha, I'm right back to the start. What I want to do is find k. So it's exactly the same. K is equal to the square root of 1 squared plus -3 squared. K is equal to 1 plus 3. K is equal to the square root of 4. K is equal to 2. And we've found that. The next thing we want to find, as in all the others, is alpha. And we do that in exactly the same way. K sin alpha over k cos alpha. K sin alpha is equal to -root 3. K cos alpha is equal to 1. In exactly the same way, we cross that off. Sin alpha over cos alpha is equal to tan alpha. Tan alpha is equal to -root 3. And it's a negative. Whenever there's a negative involved, we've got to decide which quadrant is it in. So we go back to our two equations here. K cos alpha is 1, so the cosine is positive. Which two quadrants would it lie in if it was the cosine was positive? So here and here. K sin alpha is equal to negative. Which two quadrants would it lie in if the sine was negative? It would be in this quadrant or this quadrant. So we've got now the tan of alpha equals -root 3, and its alpha is in the 4th quadrant. Again, as always, we want to get our value in the 1st quadrant. Tan alpha is equal to root 3. If it's in the 1st quadrant, it would be positive. Another exact value, now this could be a paper where you do not have access to your calculator. The tan of 60 degrees is equal to root 3. Not our answer, that's the answer in the 1st quadrant. And we want our answer in here. So it would be 360 minus 60. It would be equal to 300 degrees. So that's us found alpha. Alpha is equal to 300 degrees. Now let's finish off as we have in all the other examples. We were asked to express cos x plus root 3 sin x in the form k cos x plus alpha. K cos x plus alpha. And we've found our value for k and we've found our value for alpha. So cos x plus root 3 sin x is equal to k, which is 2, cos x plus alpha, which is 300 degrees. Thank you very much.